finding the equation of a circle. Now we often have to find the equation of a circle, and to do that we need to know the centre of the circle and the radius. But this information is not always given to us directly, so we have to sometimes use algebra or geometry to find these. We need 3 important geometry results in order to use geometry with the circle. In this first result, we're told the perpendicular from the centre of a circle to a chord bisects the chord. So if we have a circle here and we drop a perpendicular from the centre of the circle down to the chord, then we notice we have bisected this chord. So AB is the chord, and we've dropped a perpendicular down from the centre C. It hits the chord at M, so AM is the same distance as MB. Now this second geometrical result is a corollary of the first one. So in the second case we say that if we have the perpendicular bisector of a chord, so here's the chord, if we construct the perpendicular bisector of this, well then this perpendicular bisector will actually contain the centre of the circle. Now this second result is particularly useful if we have 2 chords, because if we look at the chord AB and we draw on the perpendicular bisector of it, we know the centre is somewhere along this line L. Similarly, BC is a chord and we get a perpendicular bisector of it, and we know that the centre lies somewhere along this line M. So the centre lies on the line L and it lies on the line M, so therefore the centre is actually the point of intersection of those 2 chords. And in the third result, we see that the perpendicular to a tangent, so if we have a tangent here and we have a perpendicular line drawn to the tangent, then that line goes through the centre of the circle. So of course it's a tangent at the point of contact, and that goes through the centre of the circle. We have to look at 3 different types of questions where we have to find the equation of a circle, but we're not given directly the radius or the centre of the circle. And the first type of those is where we're given 3 points on the circle. So we'll have a look at one of those. Now in this question we have to find the equation of the circle, which passes through the points 0, 0, minus 2, 4 and minus 1, 7. Now we can see we have a sketch of the circle drawn here, and we know that each of these points has to satisfy the equation of the circle. So each of these points has to fit into the equation x squared plus y squared plus 2gx plus 2fy plus c equals 0. So we'll just go through each of these points in turn. Taking the first point, 0, 0, we get 0 squared plus 0 squared plus 2 times g times 0 plus 2f times 0 plus c equals 0. Now this fairly quickly reduces to give us c equals 0, which is very handy. We now take the second point, minus 2, 4, and we plug that in. So we have minus 2 squared plus 4 squared plus 2g times minus 2 plus 2f times 4 plus c, which is 0, equals 0. And working that out, we get 4 plus 16 minus 4g plus 8f equals 0. In other words, minus 4g plus 8f is equal to minus 20. So we have an equation there in g and f. And we take the third point, being minus 1, 7. Plugging that in, we get minus 1 squared plus 7 squared plus 2g times minus 1 plus 2f times 7 plus c, which is 0, equals 0. That gives us 1 plus 49 minus 2g plus 14f equals 0, or minus 2g plus 14f equals minus 50. So we now have 2 equations involving g and f, and we'll solve them simultaneously. So now these are the 2 equations we're going to solve simultaneously. First equation is fine, minus 4g plus 8f equals minus 20, and we'll multiply the second equation by minus 2, which gives us 4g minus 28f equals 100. And we just add those two equations, giving us minus 20f is equal to 80. In other words, f is equal to minus 4. We sub that back into one of the equations. We might take the equation minus 2g plus 14f equals minus 50. Minus 2g plus 14 times minus 4 equals minus 50. Minus 2g minus 56 equals minus 50. Minus 2g is equal to minus 50 plus 56. Minus 2g is equal to 6. So g is equal to minus 3. So we now know the value of g and f. And of course that means that the centre of the circle, which is minus g minus f, is equal to 3, 4. And we now just have to find the radius of the circle. Well, of course the radius is the distance from the centre of the circle to any point on the circle, and 0, 0 is on the circle, so that's easy enough to find. So we use our distance formula here, and it is the distance, of course, using the points x1, y1, x2, y2, and we use the formula x2 minus x1 to be squared plus y2 minus y1 to be squared. And that's the square root of 0 minus 3 to be squared plus 0 minus 4 to be squared. Putting that into our calculator, we get the square root of 25, which is 5. So we now have a circle with a centre, 3, 4, and the radius equals 5. So the equation of that circle is x minus the h to be squared plus y minus k to be squared is equal to r squared, where of course the centre is hk. And that gives us x minus 3 to be squared plus y minus 4 to be squared equals 5 squared, which is 25. So that's the equation of the circle that we were being asked about. We could also do this question another way. Let's look at the diagram again. We notice here that we have the point from A to B is a chord of the circle. And we know that the centre of the circle lies on the perpendicular bisector of the chord. In other words, if we were to find the midpoint of this chord and find the equation of this bisector here, we know that the centre of the circle lies on that chord, or on that line. Equally, if we look at BC, that's another chord, and we could do the same thing, get the centre of that chord BC, find the perpendicular bisector of the chord BC, and we know the centre of the circle lies on that line. So in other words, the centre of the circle lies on the line L, and it lies on the line M. We could find the equation of each of those, and then using simultaneous equations we could find the centre of the circle. Once we know the centre of the circle, then we can work away as before and get the radius, it being the distance from the centre of the circle to any point on the circle. So I want you now to pause the video and look at this question again, and this time find the centre of the circle using the fact that it lies on each of the bisectors of these chords. So try that one now, please.